All right, guys. Welcome to day two of Unit 3.1. So, yesterday you finished. ooh, you finished the your turn slides. So you started with the gray boxes, and you went and you worked through these six problems. So today we're going to do a little bit more practice. You will find posted Unit 3.1 activity, and we're going to do these match mats. So there's two slides. We're going to work through the number one together, and then you will complete the number two on your own. So we're going to work on number one today, and these are going over the complementary, supplementary, and vertical angles. So right now I'm just going to go ahead and present to make it a little bit bigger. That's not what I wanted. There we go. So for each of these boxes, we need to solve and find what it's asking for. So this box is asking for X. So we need to find either angle X or X in an equation. So let's take a look. Okay, right here I see 2X minus 11 right here, and it wants us to solve for X. Well, how would we solve for X? We can see that this angle plus this angle right here, that makes um, a line. They're a linear pair. Or we can use what we know about vertical angles, and we know that vertical angles are complementary or are the same measure. So we can see that 2x minus 11 is equal to 105 degrees. Well, that's going to be much easier for us to solve. So let's get out a pencil and paper. And we're going to do 2x minus 11 equals 105. So here's our 2x minus 11. Hopefully it'll focus back in on us. There it goes. So 2x minus 11. So our first thing is we want to get our x's by itself. So we have minus 11. So we're going to add 11 to each side. And 105 plus 11 is 116. That is a 1. And we know that 2x is really 2 times x. So we're going to divide by 2. And we're going to divide by each side by 2. And this is going to give us x equals 58. So x equals 58. So what we'll do is, now that we know x equals 58, we can come down here. We see that here's our 58. And bam, we put it right there. So let's see what we can solve for next. So next, if we just go straight down, it wants to know z. It wants to know z. So let's find either angle z or z in an equation. And I see 8z plus 2 right here. So now we need to figure out how we can solve for z. Well, we have this angle right here. We know that it's 8z plus 2. And we know that this angle right here makes it a linear pair. But we don't have anything for f. But we do have the measure of the vertical angle that is to 8z plus 2. And this is marked as 90 degrees. 90 degrees. So if its vertical angle is 90, that means that this is going to be equal to 90. So we have 8z plus 2 equals 90. So here we have 8z plus 2 equals 90, not 9. So we're just going to do a little algebra. We have a plus 2 here, so to get rid of that, we're going to subtract 2 from both sides. That'll give us 8z equals 88. 8z is really 8 times z, so the opposite of multiplication is division. So we divide by 8, and z equals 11. Z equals 11. So we come back over here. Do we have 11? We sure do. If we start finding that we don't have answers here, then we need to check our math. Let's see what we can solve for next. Let's go ahead and we'll find y. Let's find y. All right. I see y is 9y minus 5, and then I have 8y here. So, and we know that these two are vertical angles because they are across from one another. So 9y minus 5 is equal to 8y. And we know this because we can say for our story that our two parts are equal or are congruent. They're going to be the same number. So 9y minus 5 is equal to 8y. So let's solve. So right here, we have our 9y minus 5 is equal to 8y. So let's get our variables to one side and our digits to the other. So if we have minus 5, we're going to plus 5 to both sides. So then we have 9y equals 8y plus 5. I know, it looks weird, but hang with me. So we want to get these y's over here to this side. So this is a positive y. So we're going to subtract 8y. We're going to subtract 8y. That's going to give us 1y, or just y, and y is going to equal 5. Because we brought our 5 down here. We subtracted our 8y here, and it gives us 5. So now we're going to come back to our options here. Do we have a 5? We sure do. We know we've done something right. And we've got our 5 there. Great job. Now let's let this open back up and we'll see what we can solve for. So Our next option, let's see. Let's just look at the measure of angle GED. GED. So the measure of angle GED is going to be right here, GED, because our E is always, our middle letter is always our vertex. So GED is 2x minus 11. Well, how are we going to find the measure for that? We know that this angle, GED, right here, plus BEG would be a linear pair. But we also know that vertical angles are the same measure. Vertical are the same measure. So if we know that the vertical angle to GED is 105 degrees, then GED is going to be 105 degrees. And we just so happen to have 105 degrees here. So we just label it right there. Next on our list, let's see if we can make it just a little bit bigger here without having to present it each time. That'll do. That'll do. So we have the measure of AED. So we need to find AED. AED. So angle AED is going to be right here. We have AED. AED. And we know that we don't have a measure or anything here for AED, but we are lucky enough to have already found, or we already know that it has a linear pair, that AED and AEB right here, they both would add up to 180 degrees. So that'll be easy to solve. So our part plus part equals whole. So it would be, we'll call the measure of angle AED, we'll call that just E. So E plus 105 equals 180. So we have our part plus our part equals our whole. To get our E by itself, we're going to subtract 105 from both sides. And so 180 minus 105 leaves us with 75. So 75 degrees. So the measure of angle AED is going to be 75 degrees. We come over here. Sure enough, we have a 75, so we must have done something right. And we'll place it right there. Next, we're looking for the measure of angle KON. KON. Oh, so we're going to be down here on this figure. Oh, not to that one. So KON right here. KO, because our middle letter is our vertex. N. Well, KON is already marked for us. We know that KON is 9y minus 5. Guess what, you guys? We've already solved for y. So we've already solved for y, so we can just put that in. So 9y minus 5. Which one of these was y? Nope, that's z. Y is 5. We've already solved for that. So all we have to do, guys, is plug in our numbers. So 9y minus 5. Well, we know that y is 5. So 9 times 5 minus 5. So we're just going to solve through. As simple as that. 9 times 5 is 45. Minus 5 equals 40. So it equals 40 degrees. So let's come over here. The measure of KON is 40, and we have 40 right here, so we must have done something right. Set that right there. Bring that on over. Our next question is the measure of JFJ. JFJ. So it's going to be on this figure right here because F is right here. So I'm sorry, GFJ. GFJ. Well, our figure tells us that angle GFJ is 8Z plus 2. Well, how should we go about solving for this? We know that this angle and this angle would give us 180 degrees because these two angles form a linear pair. But we also know that vertical angles are complementary and have the same measure. So the vertical angle to JF or GFJ, is HFI, and HFI is marked as a right angle, which is 90 degrees. So we know that 8Z plus 2 has to equal 90 degrees. Certainly enough, we have a 90 degrees, so let's move it over here. So angle GFJ, I am struggling with that, is 90 degrees. For our next trick, we're going to look at the measure of angle LOM. LOM. So here we go. We have angle LOM right here. O is in the middle because it's our vertex. And we know that LOM is 8y. Well, we already solved for y. So we don't have to figure y out. We just have to plug it in. So 8y is LOM, and we know, because we just used it, that y is equal to 5. So here we have 8y, so this is really 8 times 5, and 8 times 5 equals 40. And you know what? We can check it. 40 degrees, sorry. And we can check it because our vertical angle right here of KON is 40 as well. So this is KON, and this is LOM, and they're vertical angles, and we have just proved that they equal the same. So we'll come over here. Do we have a 40? We do have another 40. So we'll bring that over here. LOM is equal to 40, so we'll cover that right on up. All right, for our next trick, we are looking for the measure of LOK. LOK. Well, here we have LOK. We see that it has a vertical angle, but we don't know the measure of it. What it does have is it forms a linear pair with this angle right here. And we know that the angle of KON is 40 degrees. And we don't know the measure of LOK, but we'll just call that K. But when we have two angles that form a linear pair, we know that that equals 180 degrees. So we can tell our math story with what we have. So right here, we have our measure of our part of one of our pairs. So we have 40 plus our other part we don't know equals 180. So to get our k by itself, we're going to subtract 40 from both sides. And that's going to give us k equals 140 degrees, 140 degrees. And we got that because we know this angle right here, 9y minus 5 is 40, plus this angle right here will give us 180 degrees because these two angles create this straight line right here. And 40 plus 140 is 180. Great job. Oh, and we have a 140 right here. Maybe. There we go. Our next problem is the measure of angle JFI. JFI. So let's find JFI. So here's the measure, or here's angle JFI. F's the vertex, so it's in the middle, JFI. We see that we know we can solve for this linear pair because we've already solved for Z, but we have an easier way. Angle JFI and angle HFI form a linear pair. Not only do they form a linear pair, they're going to be, this is a 90-degree angle, so these angles are going to be congruent because 180 divided by 2 is going to be 90. So 90 plus blank is going to give us 180. So we know that 90 plus, we'll call that J, equals 180. So right here we have 90 plus J equals 180. So to get J by itself, we'll subtract 90 from both sides. And J is going to be 90 degrees. Awesome. So really, we didn't even have to do any kind of math here because we knew that this linear pair, this degree was already marked. It was already 90 degrees. Oh, what did I mess up here? I'm not sure. But let's move on. We have the measure of angle GEB. So we need GEB. Let's find our diagram. Right here. GEB. So GEB. Well, we know that angle GEB and AEB form a linear pair. And we already know the angle for one of our parts. So we can easily do part plus part equals whole. So we have 105 plus, we'll call this G, equals 180 because a line has the measure of 180 degrees. So we have 105 plus g equals 180. So to get g by itself, we're going to subtract 105 from each side. And g is going to equal 75 degrees. So GEB is 75 degrees. All right, we're on our last one, HFG. HFG. It's right here on this diagram. So we have HFG. Well, we know that HFG and HFI form a linear pair right here. And we already know that HFI has a measure of 90 degrees. So 90 degrees plus blank is going to give us a 180 degrees. So just like we did before, we're going to tell our story with what we have. We have 90 plus, we'll call that G again, equals 180. So I have that written down here. We know that our first angle is 90 degrees. Plus, we don't know, but it's going to equal 180. So part plus part equals whole. To get this angle by itself, we're going to subtract 90 from both sides. And G is going to equal 90 degrees. And a way you can tell that is any adjacent angles, when you have two perpendicular lines, are going to be 90 degrees. So these two lines here are perpendicular. If one of these angles is 90 degrees, they're all going to be 90 degrees. All right, so we worked through math number 1. You today are going to work through number 2 on your own. You're going to work through just like we did on the other ones. Solve for these simple ones first, and then start working your way through your angles. Remember, if it is a 90-degree angle, it'll be marked with the boxes. And you just tell your story. So this has 2 parts, so part plus part equals a whole. This has 2 parts, part plus part equals a whole. This one has 3 parts, 1, 2, 3. So that would be part plus part plus part equals a whole. And remember, adjacent angles are going to be the same measure if it's a right angle. If you have any other questions, please reach out. You have 1, 2, 3, 4, 5, 6, 12 problems to work through. And I will be here if you need me. Have a good one.